Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Space Exploration Observatories, Humanity's Inventions to discover the mysteries of the universe. The focus points are as follows: Space Exploration Observatories and examples of space-based observatories. The universe, a space of creation that includes all of existence, fundamental interaction, physical processes, galaxies, space, and all forms of energy and matter has captured human's imagination for many centuries. In the universe, light and darkness coexist. For many years, space observatories, also referred to as space telescopes, have been launched into outer space to explore and collect data about distant planets, galaxies, asteroids, and other celestial bodies. Space telescopes are satellites which could map the entire sky or focus on selected astronomical objects or parts of the sky and beyond. In comparison to the ground-based observations, space telescopes are not affected by the absorption or scattering of certain wavelengths of light. Obstruction by clouds and distortions due to atmospheric refraction, such as twinkling. They can observe dim objects during the daytime and they avoid light pollution. Examples of space observatories are Chandra X-ray Observatory, Euclid, Gamma Ray Space Telescope, Hubble Space Telescope, Integra, International Space Station, Imaging X-ray Planetary Explorer, James Webb Space Telescope, NASA, Piper, and a host of others. Through the help of Hubble Space Telescope, astronomers were able to trace evolution and formation of galaxies. They discovered that most galaxies contain supermassive black holes. Gamma Ray Space Telescope, a powerful space observatory, detected gamma rays, the most energetic form of light. The Swift Space Observatory, a space satellite launched on 20 November 2004, studied gamma ray bursts, the most powerful explosions in the universe and other cosmic objects and events. Swift has three wavelength telescopes collecting data in visible, ultraviolet, X-ray, and gamma ray light. Space Exploration Observatories. A space telescope or space observatory is a telescope in outer space used to observe astronomical objects. The first operational telescopes were the American Orbiting Astronomical Observatory, OAO2, launched in 1968, and the Soviet Orion 1 ultraviolet telescope aboard the space station Zayut 1 in 1971. Hubble Space Telescope, as seen from departing Space Shuttle Atlantis, is shown in this picture. Since the Earth's atmosphere absorbs the vast majority of X-rays, they are not detectable from Earth-based telescopes. Therefore, space-based telescopes are required to make these observations. Space telescopes can also observe dim objects during the daytime, and they avoid light pollution, which ground-based observatories encounter. NASA's Swift spacecraft, launched in 2004, is shown in this picture. Space-based observatories are divided into two, namely satellites which map the entire sky, astronomical survey, and satellites which focus on selected astronomical objects or parts of the sky and beyond. Space telescopes are distinct from Earth imaging satellites, which point toward Earth for satellite imaging, applied for weather analysis, espionage, and other types of information gathering. Wavelength sensitivity of Hubble, Webb, Raman, and other major observatories is shown in this picture. There are various examples of space-based observatories, and some of them are as follows: Chandra X-ray Observatory, Euclid, Gamma Ray Space Telescope, Hubble Space Telescope, Integra, International Space Station, Imaging X-ray Polarimetry Explorer, James Webb Space Telescope, Neil Green's Survey Laboratory, NASA, Piper, wise and near-wise, and extreme. Chandra X-ray Observatory, an example of space-based observatories, is a space telescope launched aboard the Space Shuttle Columbia during the STS-93 by NASA on July 23, 1999. It was specially designed to detect X-ray emission from very hot regions of the universe. Chandra X-ray Observatory is part of NASA's fleet of great observatories, along with the Hubble Space Telescope, the Spitzer Space Telescope, and Compton Gamma Ray Observatory. Artist illustration of the Chandra X-ray Observatory is shown in this picture. Chandra was sensitive to X-ray sources 100 times fainter than any previous X-ray telescope, enabled by the high angular resolution of its mirrors. It is an Earth satellite in a 64-hour orbit, and its mission is ongoing as of 2024. Chandra allows scientists from around the world to obtain X-ray images of exotic environment so as to help them understand the structure and evolution of the universe. Artist's concept of Chandra X-ray Observatory exploring the universe is shown in this picture. Euclid is an European Space Agency mission with critical contributions from NASA that aims to explore two of the biggest mysteries about the universe: dark matter and dark energy. Two instruments, a near-infrared spectrometer and photometer, are used by the Euclid to understand dark matter and dark energy by measuring the expansion of the universe. ESA's Euclid mission illustration is shown in this picture. Fermi Gamma Ray Space Telescope is another example of space-based telescope. It detects gamma rays, the most energetic form of light. The satellite was launched on June 11, 2008 as the Gamma Ray Large Area Space Telescope. Fermi enables scientists to address questions across a broad range of topics, from cross-stellar remnants like pulsars and the origin of high-energy charged particles, such as cosmic rays. Fermi Gamma Ray Space Telescope is shown in this picture. Hubble Space Telescope is the first astronomical space observatory placed into orbit around Earth with the ability to record images in wavelengths of light, spanning ultraviolet to near-infrared. Hubble Space Telescope was launched into low Earth orbit on April 24, 1990. The picture here shows the Hubble Space Telescope as it was returning to orbit as an improved telescope after its servicing mission. Hubble is the only telescope designed to be maintained in space by astronauts. 5 space shuttle missions have repaired, upgraded, and replaced systems on the telescope, including all 5 of the main instruments. Hubble's orbit outside the distortion of Earth's atmosphere allows it to capture extremely high-resolution images with substantially lower background light than ground-based telescope. The Hubble Space Telescope is shown in this picture. ESA's Integral mission, launched on October 17, 2002, observed the universe in gamma ray, X-ray, and visible light. It uses spectroscopy and wide field of view imaging to study gamma ray bursts, supernova, X-ray binaries, active galaxies, and other phenomena. The mission was conceived as an observatory led by ESA, with contribution from Rosalind and NASA. Exploded view of the Integral spacecraft is shown in this picture. International Space Station is a microgravity laboratory orbiting Earth, which has been continuously occupied by humans since 2000. It is a collaborative multinational project between NASA, Japan Aerospace Exploration Agency, European Space Agency, Roscosmos, and the Canadian Space Agency. Illustration of International Space Station is shown in this picture. The space station is a robust platform which has provided researchers around the globe with data that can help determine what the universe is made of and how it all began. International Space Station scientists are discovering fundamental knowledge through research on colloids, bubbles, and fluid behavior. Astronauts performing spacewalk outside the International Space Station is shown in this picture. Imaging X-ray polarimetry explorer is another example of space-based observatories. NASA's ISPE is a space-based observatory which uses 3 identical X-ray telescopes to detect polarized X-rays from extreme cosmic objects like black holes, neutron stars, and pulsars. The observatory, which was launched on December 9, 2021, is an international collaboration between NASA and Italian Space Agency. NASA's X-ray astronomy mission is shown in this picture. James Webb Space Telescope is a space telescope designed to conduct infrared astronomy. Its high-resolution and high-sensitivity instruments allow it to view objects too old, distant, or faint for the Hubble Space Telescope. Its instruments aided investigations across many fields of astronomy and cosmology, such as observation of the first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. Artist rendering of the James Webb Space Telescope is shown in this picture. Neil Gray's Swift Laboratory is another space-based observatory. Swift Observatory, launched on 20 November 2004, is a space satellite that studies gamma ray bursts, the most powerful explosions in the universe, and other cosmic objects and events. Swift houses 3 multi-wavelength telescopes, collecting data in visible ultraviolet. To determine the origin of GRBs and to use GRBs to expand understanding of the young universe. Neil Gray's Swift Observatory is shown in this picture. NISA is another example of space-based observatory. It is an X-ray observatory that studies neutron stars and other phenomena from its home aboard the International Space Station. NISA enabled rotational resolved spectroscopy of the thermal and non-thermal emissions of neutron stars. View of the neutron star interior composition Explorer NISA payload is shown in this picture. Piper is a balloon-borne instrument that measures and studies the polarization of the cosmic microwave background and diffuse interstellar dust. It is designed to map 85% of the sky and enable scientists to look for signs of primordial gravity waves, which was created by the rapid expansion of the universe shortly after the Big Bang. The mission floats to the edge of Earth's atmosphere to find evidence to support the theory that our universe expanded by a trillion times immediately following the Big Bang. The Mulder Inflation Polarization Explorer is shown in this picture. NEOWISE is another example of space-based observatories. The mission was designed to map the entire sky in infrared light. It discovered the coolest and nearest brown dwarf and the most luminous galaxies in the universe. In 2013, it was renamed NEOWISE and was given a new mission to help NASA identify and study near-Earth objects. Artist's concept of near-Earth objects, Wide Field Infrared Survey Explorer, is shown in this picture. X-ray Imaging and Spectroscopy Mission is a space telescope mission of the Japan Aerospace Exploration in partnership with NASA to provide breakthroughs in the study of structure formation of the universe, outflows from galaxy nuclei, and dark matter. Extreme was launched on 6 September 2023 and was successfully inserted into orbit on the same day. X-ray Imaging and Spectroscopy Mission is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Space Exploration Observatories, Humanity's Inventions to discover the mysteries of the universe, presented by Dr. Ayeshola Ogundele, with the focus points space exploration observatories and examples of space-based observatories. Thank you.